Hello and welcome. My name is Alan, and today we're going to be doing some more videos on science. Today we're going to be talking about the four fundamental forces of nature. There are four agreed upon fundamental forces. You can sometimes find articles on, is there a fifth fundamental force? They'll give their theories and stuff, but nothing has been agreed upon as being a fifth fundamental force. In nature, there are four fundamental forces or fundamental actions, interactions, as they're called in physics. They are the gravitational, the electromagnetic, the strong nuclear force, and the weak nuclear force. The forces interact slightly differently. Gravitational and electromagnetic actually produce significant long-range forces. This is off Wikipedia, whose effects can be seen directly in everyday life, while the strong and weak nuclear interactions actually are forces at the subatomic level that govern atomic or nuclear interactions. The first one we want to talk about, gravity. It is what pulls things to a point. You can't exist on this planet without gravity. Basically, it's when bodies are attracted to one another. So, one body, yourself, and the Earth is the other one. Well, the Earth attracts, pulls on you a lot more. And so that's how we manage to stick to the planet without like just floating off into the sky, into space. It helps produce weight in objects. It affects um, the gravity of the moon affects tides in the oceans. Even the formation of the universe itself, gravity has a hand to play in that because when the objects gather together, the bigger they are, the stronger of a gravitational pull they have. It's what allows things like um, the space station to stay in orbit, just flying off. Um, but it stays from crashing because it's going at a certain speed. So the Earth it creates just enough of a pull on that space station to hold it in place as it goes around. Same with the moon. It's held in place just enough. It slowly got further out from the Earth. But yeah, it keeps moons in orbits around planets. Like I was saying earlier, the whole universe formed simply because of one of the big reasons is gravity. Because when the particles get together and get big enough, they form enough mass to have a gravitational pull of their own. And so they produce their own stars, their own planets, to give you an idea of how gravity works. Now, electromagnetism is the study of the electromagnetic force in physics. And occurs between electrically charged particles. It is composed of carried by electromagnetic fields composed of electric fields and magnetic fields. It creates light through electromagnetic radiation. Yeah, sometimes it's called the Lorentz force, which includes both electricity and magnetism as different manifestations of the same phenomena. The electromagnetic attraction between atomic nuclei and orbital electrons holds atoms together, so it even affects on the molecular state. We see the effects that electromagnetism can produce, and is basically seeing electricity and magnetism as parts of the same interaction. On Wikipedia, it reads there are several ways to read electromagnetism as ampere for electric current, coulomb for electric charge, farad for capacitance, Henry for inductance, ohm for resistance, Siemens for conductance, Tesla for magnetic flux density, volt for electrical potential, Watt for power, and Weber for magnetic flux. So yeah, as you can see, there are several ways to measure it, but they all involve either the magnetic or the electric readings. Now, we can see its effects in things such as lightning, um, and of course, magnets. Light itself can be a result of electromagnetic radiation, as mentioned earlier, which is part of the different can be detected in different ways through radio waves, microwaves, infrared, um, ultraviolet light, visible light, X-rays, and gamma rays. Yeah, all part of the electromagnetic spectrum. Now, let's take a look at the strong nuclear force, or the strong interaction. This is part of the molecular interactions that take place on the molecular and atomic levels. It is approximately 137 times, this is according to Wikipedia, as strong as electromagnetism. 10 to the 6th power times as strong as the weak interaction, and 10 to the 38th power times as strong as gravitation. The strong nuclear force confines quarks into hadron particles, such as the proton and the neutron. So, yeah, we're really getting down into the building blocks here. It is the force that helps create uh, the nuclei of atoms. It can be observable at two ranges and mediated by two force carriers. It is the force that binds protons and neutrons together to form a nucleus of an atom. And even on a smaller scale, it is the force that holds quarks together to form protons, neutrons, and other hadron particles. So, yeah, a very, very important thing. Um, it's believed that the strong nuclear force is why wep- nuclear weapons such as uh, the hydrogen bomb and the uranium or plutonium based fission bombs actually are so devastating because it's the release of that strong nuclear force. And then the last one we want to speak about is the weak force, or the weak nuclear force, or the weak interaction. It also affects subatomic particles and is responsible for radioactive decay of atoms. It also participates in nuclear fission. The actual effective range of the weak force is only limited to subatomic distances. It is the only force that can change one type of quark into another when you get on the subatomic level. It is the only interaction that violates parity symmetry. It is also the only one that violates change parity symmetry. Both electrically charged and electrically neutral weak force interactions are mediated by a force carrier particle that have significant masses, an unusual feature which is explained in the standard model of the Higgs mechanism. One of the reasons for the decay of atoms, which why they have half-lives. That is going to be it for this video on the 4 fundamental forces. I'll go ahead and post my sources in the description below the video. But as always, educate thyself. Think, read, study, learn. Someone tries to tell you something you have trouble believing, ask them to cite their sources. I'll see you all in the next video. I'm sorry. Until then, later.